Hi everyone, so today we'll be talking about the thin converging lens or the convex lens, and this is the very last part of the light chapter. Okay, so there are different types of lenses. There are converging and diverging lenses. Okay, for converging lenses, the parallel light rays are brought to focus at a point. If you have ever tried to focus the sun's rays using a magnifying glass, then you have actually seen one of these lenses. Okay, however, for diverging lenses, this is slightly different. Parallel light rays, right, tend to be spread out, which means that if the light rays go in parallel, when it comes out, they will actually spread out. Many of you probably have a set of diverging lenses with you, which is a pair of spectacles. These would be diverging lenses. So, some uses of lenses in everyday life. Okay, one basic use is to make stuff look bigger, as you can see with these two lenses below. Magnifying glass to make things look bigger. Binoculars use lenses as well. Lenses for spectacles, like we have talked about. Telescopes and contact lenses. An LCD projector also uses lenses. Cameras also use lenses. So a lens, right, can be thought of as a set of blocks and prisms. So, for example, over here, you can see that if it's a perfectly square block here in the middle of the converging lens, the light would just pass through and will continue to go straight without changing. However, once you move like one block to the top, you can see that these two sides are a little bit slanted towards each other. And when they are slanted towards each other, then the light that comes in will actually be refracted towards the center. Then you can see that as you go nearer to the edge of the lens, it becomes more and more slanted towards each other, and therefore this makes the light ray bend even more. And lenses have this particular property in that it directs all of the rays towards a single point, and this would be called converging lenses. The opposite thing happens with diverging lenses, where they actually spread out the rays, as shown below. The syllabus mainly teaches us about converging lenses. A converging lens is able to converge a parallel beam of light passing through it to a point. So, if there's parallel beams coming towards this lens, it would all converge towards this point here, the one with the F. We'll talk more about it later. Alright? This position F is determined by how fat or how thin this lens is. So let's talk about some technical terms. The first one is the optical center C. This is the center of the converging lens, which lies on the principal axis. Okay, yeah, so this is the optical center C. You can see that the lens is thick. If you draw a line through, the optical center C will be in the middle. Now, the next one is called principal axis. It is a horizontal line passing through the optical center. This is the horizontal line passing through the optical center. Make sure that this thing is a right angle to the lens. Next one is called a focal point. The focal point, or the principal focus F of the converging lens, is the point on the principal axis which all the rays that are originally parallel and close to the axis, after they pass through the lens, they would converge, and they will all converge into this point over here, and this is called the focal point. Now the next one is called the focal length. The focal length of the lens is the distance between the optical center and the focal point F. So this length over here is the focal length. Now we have two different things. We have the object distance and the image distance. The object distance, U, is the distance between the optical center and the object. Optical center will be the center, and an object would be here. So the object distance, U, would be this distance. Now, this object, right, once light comes from the object, passes through the lens, it would form an image. And this length over here would be called the image distance. It is the distance between the optical center and the image.